So hello everyone, this is Mod Zero again and welcome to another video. So today let's check out solid principles and design pattern. ठीक है, तो देखेंगे कि इसकी जरूरत क्यों पड़ी, why do we need it. So first let's discuss about the problem that we face before solid principles. Yeah, so basically देखो ऐसा होता था पहले कि developers often write the code but that worked initially well, but it became difficult to change as the application grew. So that means whenever our code and classes were scaling, yeah, we don't know anything how to maintain or how to reuse it. And basically our code was not future proof. Like for example, if you want to change anything at one class, so your classes are so tight coupled that it introduces some other changes on another class, which might or might not be dependent directly on that. Now let's see an example. For example, we have this DB class. So it will have a lots of functions here, and there is one another function like build connection function, and we are creating an instance of MySQL class here. Let's say there is one user class that is using the DB build connection thing, and let's say in future you want to change this MySQL and you want to use now Postgres. But for this you need to change this code again. Na? You will be removing MySQL or maybe and you are adding an implementation of PostgreSQL again. And let's say you have another function here that was, let's say it's a query of get all user. So what will happen now? This was initially a MySQL code. Let's say it was implementing a MySQL query. Now that you have changed this post to PostgreSQL, maybe some things needs to change here too because it is dependent on MySQL. Now this creates a lot of tight coupling between your classes, and maybe this user is one class, you can still do the changes. But let's say you have 10 classes, right? And consider you have a giant e-commerce app, so it will be a nightmare for you if your classes are very tight coupled between, right? Any new feature will be like 100 plus changes in 10 different files. So we don't want that, right? So this was the problem that we are facing when we are not following the solid principles. Because as the application grew, as your code scales, you need them to be maintainable, right? This example, changes in one feature will affect many unrelated features, like for example, classes, and you will be having a larger tight coupling. In fact, maintaining very large classes is also a problem in itself, which can be solved using the solid principles. And without solid principle, it was harder to maintain and reuse the classes basically. Right. So after solid, all these problems were solved, and we as a developers are happy again. Right. So solid are the set of rules or the guidelines that you need to follow so that your overall architecture of code becomes future proof. Right. So let's proceed ahead. Solid principles will help you write the software that will be easier to understand, easier to change, easier to test, in fact, easier to extend. Means whenever you are having a new feature requirement, you can do that via minimal change in your code, right? So it is less likely to break when your requirements change, and it definitely reduce the tight coupling between it, and it will make your code more maintainable. So let's see what each words stand for. So S stands for a single responsibility principle. So what it tells is a single class should only have one reason to change, which means your one class should only take care of your any one of the responsibilities, not many. So let's see an example. Let's say you are having a class, let's say invoice service, and you have multiple functions like calculate the total price, and it will be saving the invoice in your database, and let's say it will send your invoice to the email. So you can notice all these functions are related to invoice itself, right? But these functionalities, I mean the purpose, those are different, and you can observe it has more than one reason to change. Let's say instead of database, you want to use some another mechanism, let's say cloud, or maybe you want to save it on a file. So you again needs to change this the implementation here. And let's say this sending email example. Let's say you want to add another method like send notification via WhatsApp. So again, you need to add a function here and add an implementation. Besides that, the purpose which it is meant to be, like calculating total and all, if there is another a change in logic, then again a new reason to change. Now observe a problem here. So this class has basically three responsibilities. It is having a business logic, let's say calculating the price, persistence, that is saving to the database, and also sending the notification, which which is introducing three reasons to change. Now generally what should be the case ideally? It should only deal with the business logic. But maybe in the start you have developed a class just because it is related to invoice, you have added all your functionalities into a single class, and that will arise a problem in the future. So how to resolve it? So let's say this is a example that is following our single responsibility rule. So what we did, we broke down the class into more smaller discrete classes. Right, this is one class, yeah, invoice calculator, and this is having the business logic. You will have another class that is invoice repository, and this will take care of your persistence. And similarly, you have another class which will take care of your sending the notification. Now see, each and every class has only one reason to change. I mean, it can definitely have many much more functionalities, right? It doesn't mean that you are breaking your class into a limit that it has only one function. That's not the case. It can definitely have much more functions, but the purpose should be the same. Like this purpose is business logic, and it will only be storing the calculation part. This will be the persistent. Let's say you are having a requirement that you want to save to a file or maybe save to a cloud, then only this class will be getting changed. Similarly, if you want to add the notification feature for WhatsApp and all, only this class you will be needing to implement the change, right? So every class is having a single purpose and only one reason to change. So what will be the benefit of you that if you follow the single responsibility rule, and that definitely it will become easier to maintain, it will be easier to test, and definitely this is a main feature. It will reduce your tight coupling. Okay, so let's move on to the another acronym O, which stands for open and close principle, which says any of your software entities should be open for extension, but it should be closed for modification. Now, what does it mean? Yeah, let's see from an example. You are having a payment service class. Inside that, you have a function which will be called during the payment. And if you want multiple payment methods, let's say it's a card, let's say UPI, or maybe bank transfer, right, or maybe COD. Now, what you have done here, you're passing a type, maybe an enum. Here I have taken string. Now you're checking each and every string that if it is equals to card, this will be the logic that will be followed for the card payment. And if it is the UPI, then this logic will be followed for the UPI payment. Now let's see where the problem is. You have another feature. Let's say you want to add another feature of bank transfer or maybe cash on delivery or maybe any other method. So the problem is you again will be changing the code here for the payment service. The payment service is already tested and deployed class in your production. And then again, just for a single if statement, you will again need to test the entire payment service. And each and every time you have to modify the already tested existing code. And that's why it is said it should be closed for modification. Instead, you can extend it for new requirements. So this is the problem here. Every new payment type will require your existing code to change, just like this, and it will have a particular phase. Like for example, it can introduce bugs. Let's say you are stuck in an if-else ladder and you have very large conditional logic, and definitely it violates the stable design. So how do we resolve it? So this is the implementation in Java. You create an interface of payment strategy, and you have an abstract method called pay. And each and every payment method that you're gonna implement now or in the future, it should be the type of payment strategy, right? So you will be implementing this interface. Let's say in the class card payment, it will implement this interface. It will have its own logic. Similarly, UPI payment will have its own logic. And now this entire class will be passed here in the constructor of your payment service, right? So whatever the strategy you might have created and passed to the service, it will call its own pay method. Let's say you are creating an object here, payment service pay with card. Now let's say this object creation, we're creating a payment service with a new card payment. The new card payment will create an object of this class, And when you will call pay with card dot pay, now this strategy is already been stored here, and this will call this card payment pay method. Now see how readable and modular your code is, and it is now future proof. Let's say you are having a new payment method, let's say PayPal payment or maybe a bank transfer. You will not change the existing code. You will be creating a new class entirely, and that will implement your payment strategy. After that, you just need to change on the client's code that you want another object. And instead of card payment, you can do a new, let's say, PayPal payment. Now your existing implementation is untouched, right? So we reduce the type coupling now. And this is so much easier to maintain if you compare to before, right? And this will be the benefits that we already discussed. You're not modifying the existing code, but definitely you can extend it, right? And you are now following the open close principle. Now let's move to another acronym. The stand for L is list of substitution principle that says subclasses must be usable, right? Wherever the base class is expected. Now what does it mean is you have a parent class and you have a child class that extends your parent. Now it says wherever this parent is expected, even if you pass the child object here, it should work. It should not be the case that it is giving any exception or maybe not implemented yet. It should not be the case. Your child class should always be replaceable from your parent class. And let's see an example on that. You have a class bird, right? It has a function, a simple function, fly function. But let's say you are having a class, another class that is penguin. Now you know penguin is a bird, right? So it will inherit your bird. But you definitely know penguin are the birds that doesn't fly. Now, if you want to override this function, you have to do something like that. Just because penguin doesn't fly, you cannot call this function. It is unsupported operation. Now the problem here is where in in your code, wherever your bird class is expected, and let's say your because your client code is not aware of your any child classes, right? It is just here. I want an instance of a bird class. Now when it will try to call your fly function, you will be having a runtime exception because this is not expected. Penguins cannot fly. So what is the solution of that? What you did is you created an interface called flyable. Okay. And you are having a class bird, whichever your child classes of your parent class that can implement your interface as per their will. Okay. Now nobody, no child classes will be forced on a function that it doesn't implement. Let's say this example that you have a child class called Sparrow, which will extend the bird class and it should implement flyable because sparrows can fly and it will have the fly implementation. And let's say you have again a child class of bird, which is penguin. And right now it is not under any pressure that it has to implement the fly function. Now here, whenever the bird class object is expected, all the child class are usable there, right? So no subclass violates the expectation of the parent type. And this is what stands for list of substitution principle. Right? Each and every of your subclass can be substituted instead of the parent type without any issues. Let's move forward to another principle, which stands for I. It is interface segregation principle. So what does it mean is very important. That no client should not be forced to depend on methods that they do not use. It means that whenever you have, let's say, an interface and it has three abstract functions like function 1, 2, and 3, let's say you have three implementation class. Now we know, right? Whichever class is implementing our interface, it has to implement or give the implementation of all the abstract function. Now let's say you are having three function and let's say in your class 3 implementation, you don't want this F3 function because it doesn't have any use. But just because of the strict rules, because interface is a contract, you are bound to have any implementation or maybe any dummy implementation for your function that you're never going to use, right? So this will be, creating irrelevant behavior in future. So what does it say? You should have a smaller interface. So indirectly, it is saying you implement a smaller interface which can be discrete. Now let's see an example here. You have an interface called worker and your worker will work and your worker will eat. Now, your robot is also a worker, right? So your robot class will implement your worker interface, and your robot will have the work function, but robot doesn't eat. Now again, the problem that you're dependent on a function that you will not use or is not required. So again, you will be having this unwanted statement. To avoid that, how can we resolve it? So you can have more simpler discrete interfaces. Let's say you create two interfaces, workable and eatable, and your human class, that will be your parent class, will implement both of this interface, and it will have these two implementation. And similarly, your robot will now only implement the workable interface, and this is how it will not be, under pressure to have implementation of any heat function. The classes will implement only what they actually. Now, why this is required is because if you are having an unwanted function, you might be end up in a state where your function is not meant to be used anyways, but you are still able to use that. So it can lead you to an unwanted state, right? It will be an irrelevant behavior in production. So that's why we need to follow this principle. And at last, we have another principle, that is dependency inversion principle, which is saying that you should always be depending on the abstractions and not the concrete implementations. Now, what does it mean? It will solve our first problem that we discussed in the start of this video, that when you have this DB class, so what we were doing, we were directly having the MySQL instance, right? MySQL implementation was directly here, and this user was directly using this implementation class. Instead, what we should do, we should be having a, we should depend on abstraction. Let's say now your DB class will have this DB type, right? And now any of your implementation, SQL or Postgres, can be passed here. Okay. So that will be definitely more maintainable and it will be easier to extend, right? So that's why it is saying that you should not be directly using the concrete implementation. Instead, you should use abstraction, and in runtime, your concrete implementation will be getting passed. So let's see with an example. You have a class MySQL database and it has a save function. Now your user service will create an instance of your MySQL database, right? And in this function, it will call this db.save, and db.save will be directly MySQL implementation. Now, this is what tight coupling is, right? User service is directly tight coupled to MySQL. And now it is very difficult to switch to any different implementation, right? If you want to switch, you have to create a new implementation and you have to change the code here, right? You're again changing the existing code. And that's why these two problems are introduced. And definitely it is very hard to mock during the test. Now, what's the solution now? See, we are not directly using the concrete implementation. We have created an interface called database. Your MySQL database will implement your interface database, and it should have its own safe logic. Okay. In your another instance, let's say another implementation, PostgreSQL will have another logic of saving an entity. And now you see you are dependent on the abstraction, which is the interface database. You are not directly using MySQL or Postgres. So you are not tight coupled now. Okay. And during the construction of your class object user service, you can pass any database you want. You want SQL, you want MongoDB, right? Any database you want, it will be inserted here and it will be stored inside your database variable. And whenever you will be calling this save user function, it will call your database implementation. Right now, you can pass any database. So whatever database it holds here, it will call the dot save of that particular database. And let's say you have passed an SQL instance, it will call the SQL save only. Now, with minimal code change, you can introduce any number of your implementation, and you can directly use here, and this existing code will not be disturbed, right? So that's the beauty of this solid principle, right? So these are the benefits that we discussed, and in summary, what we can say is solid principle will help you write your software or code that will be easier to extend or future proof. So there is one analogy that I need to share. So when you have a large user base in your application, what you do system design, right? You follow the system design principle, because once your application scales, and application scales mean your user count is increasing. In that time, you need just to design the system thoroughly so that it should not break. Similar thought process is here, but it's for your code base. Now your code base will have classes, and once your classes gets increasing, mean your code is getting scaled now, right? And you will be needing to follow these rules of solid principle so that it becomes maintainable and it doesn't break in the future. Yeah. So this is all the discussion about solid principle, and I hope you're cleared. So if all these are solid principles, then what are design patterns? Okay, let's see on that. So design patterns are actually the reusable solution templates. Again, for common software design problems. Because when you're planning your code architecture and you have lots of classes, now you want to use solid principles, right? But there are some common problems that you will end up, and these design patterns will serve you the direct implementation solution, right? How you will be implementing your classes, and so that your problem is also solved and you have also followed the solid principle. So solid will tell you the rules of the good design. Design patterns are the implementation of those rules, okay, of some common problems. So they will give you a ready-made blueprints to apply those rules. So solid are like theoretical things. They are rules of the design. Design patterns are the implementation of those. So solid is like principles, and design patterns will give you the some standard blueprints. Now let's say these are some of the examples that when you're building a software or doing the architecture of the code, like you're deciding something like how your classes will look like, how your classes will communicate with each other, delegate the task and all. So you will be end up in some of the design problems that I have mentioned below, and these are only few of the design problems. There are many, right? How you will switch between different algorithms. Let's say the thing that we discussed, the payment thing. So different algorithm are like via card or via PayPal something, right? So these are some design challenges. Similarly, how will we notify many objects when something changes, how to add features dynamically, right? So this undo and redo operations are also like very interesting design problem. How to create your object safely and how to create only single instance of your class throughout your project, right? So instead of a new solution you have to think every time, developers use a known pattern, and this known pattern are called design patterns. Okay, so it is saving you for reinventing the wheel every time, and each of the common design challenges that we generally notice are being solved by design patterns following the solid principles. So I hope you are clear about what solid principles are, why do we need it, and what design patterns are, what's the difference between solid and design patterns. And definitely you have some any of your questions you can drop out in the comment section. I will try to resolve or create a new video on that. And further, we will jump on to many different design patterns, like whatever design problems that we are discussing right now. We will we will check how to implement, how to use those design patterns, right? And this will definitely will becoming useful to clear your interviews. So yeah, let's meet in other video. Bye bye.